Entanglement. Einstein called it spooky action at a distance. Basically, it's that one subatomic particle can seemingly communicate faster than the speed of light to tell another particle to have opposite spin. There are 3 axes that can each have an up or down spin. The important thing is that they are opposite and, if combined, cancel each other out. Photons. We see the photon emitted and then the photon absorbed. They have opposite spins. However, to the photon traveling at the speed of light, emission and absorption happen in the same instant, and length has contracted to 0. Where can spooky action live if 0 distance? During its singular emission-absorption event, spin is in a superstate. But when things are slowed down to our speed, the emission-absorption event is stretched out. When we break the entanglement by measuring the particle's spins, we see the spins are opposite, just like anything you break apart. I see no problem with entanglement concerning photons. It follows that all entanglement is a property of length contraction equaling 0. Electrons and quarks also experience entanglement. They are both point particles, and if not for the Higgs field, would have 0 mass. The Higgs field provides resistance, preventing them from reaching the speed of light. Seemingly, they are not getting any kind of length contraction to 0. But we see entanglement with quarks and electrons. So some element of length contraction to 0 is in play somewhere, which says to me that the Higgs field does not affect all of the particles' waveform. Some of the waveform is still allowed to travel at the speed of light and get length contraction equals 0. I imagine the edge of the particle waveform on the furthest boundary from the focus of the Higgs interference and the particle's own properties holding it back. Also, the edge would convey spin. If the edges of a waveform maintain 0 length contact with another particle, their opposite spins would cancel each other out, forming a superstate. Once entanglement is broken, their combined properties of spin, once balanced, would be opposite. So elementary particles could share the edges of their particle waveform, creating entanglement. Quarks come in 3s, making neutrons and protons, the nucleus of atoms. 100,000 times larger is the electron cloud, many of them entangled. These form molecules, cells, and us. Let's not forget the photons. What an entangled mess. Entanglement is going to look faster than the speed of light. To us, it looks like the photons travel from the emitter to the detector at the speed of light. However, the balance of spin was there at the emission, no matter the photons are our point of view. When we break the entanglement to measure spins, the spins, no matter what they are, will be the sum of the balance they previously had. The spins will be opposite from each other and able to fit back together. Particles that do not have opposite spins cannot become entangled. This is Ron Williamson. Thank you for watching.